Hello, welcome to the Unit 5 review homework help video. I will go through the entire thing. Let's do it. Okay, number 1, determine if the given coordinates are a solution to the system. So we did this a lot in 5.2 and 5.3. Oh, I just got cold. Anyways, so you have a system of equations, y equals 2x plus 4, and x plus y equals negative 5. Okay. So you have 3 coordinates that you need to try. So what we're going to do is substitute each into both equations. Remember, to be a solution, it has to work in both equations. It has to work in both equations. It has to work in both. So I don't know if this helps people, but I'm going to color code real quick. I'll make y green, green. There we go. And we'll make x be probably purple. Oh, not that. Hold on one second. Gonna make all my x's purple. Okay, there. So we're going to start with point A. We're going to substitute 1 in for x and 6 in for y. So y is 6. We're going to do the top equation first. All right. So y is 6 equals 2 times x. All right, x is 1. And then you have y equals 2x plus 4. All right, now we simplify this and see if it is true. So we get, I'm going to quit color coding, 6 equals 2 times 1, which is 2, plus 4. So you get 6 equals 2 plus 4 is 6. Ta-da! Okay, so point A works in the first equation. Point A works in the first equation. So I'm going to I'll put a little dot next to it, or a little star. Goodness. It works in the first equation. But to be a solution, it has to work in both. So we're going to substitute the same point into the second equation. X plus y equals negative 5. So go ahead and do that. Go ahead and pause me and do that, please. Okay. Anyways, so next equation is x plus y equals negative 5. So x is 1. Make it purple. So that means 1 dash y, which is 6. Would it help you guys focus on music playing in the background? I might try that. Equals, nope, not green. Negative 5. It should equal negative 5. Okay, so I just rewrote it. I substituted in 1 for x and 6 for y. Let's see if it's true. 1 plus 6 is 7 equals negative 5. So is this true? Is 7 equal to negative 5? No, they're different numbers, right? 7 is much different than negative 5, so it does not work. So that means this one has been eliminated. Can I like cross through it somehow? Yeah. Boom, that one's out. So move on to so do that with the next 2 points, okay? You have to try all 3 of them. So make sure you pause me and try that, right? Okay, so we're going to move on to B, which is negative 3, negative 2. Be careful with your negative signs. We're going to substitute into our first equation. So let me grab my green. Y equals negative 2. So negative 2 equals 2 times x, which is negative 3. Negative 3. And then make sure you rewrite your plus 4. All right, here we go. I'm going to quit color coding. Negative 2 equals 2 times negative 3, negative 6, and then plus 4. Negative 2 equals Negative 6 plus 4, negative 2. All right. Ooh, look, that is true, so that works. So once again, I'll put a little star next to it. It works in our first equation. Let's see if it works in our second one. So our second equation, x plus y equals negative 5. So x is negative 3. Negative 3. Plus y, which is negative 2. Negative 2. And that should be equal to negative 5. Let's see. Is it? Negative 3 plus negative 2 is negative 5. Negative 5 equals negative 5. Oh, look, that is, in fact, correctamundo. So this point works in both equations. So I'm going to highlight it. Let's make it yellow. That is a solution to this system. Okay, because it works in the top and the bottom equation. All right. We'll try the third one should not work because these lines should only intersect at one point, which should be negative 3, negative 2. Okay, it is. These lines only intersect once, and it's at negative 3, negative 2, but I'm going to try C just for practice. And it's always good to try all of them. That way you're double checking your math. So let's do this point. So x is negative 3, y is 2. So let's go to our first equation. So y is negative. Well, y is positive 2 this time. Oops. Equals 2 times x. X is negative 3. Plus 5. Oh, sorry, plus 4. Plus 4. Right, so you get 2 equals negative 6 plus 4. 2 equals negative 6 plus 4 is negative 2. Okay, so that is not true. 2 is not equal to negative 2. This is why you really have to be careful with your negatives. So this one did not work in the top equation. Even if it works in the bottom equation, it doesn't matter. It needs to work in both. So we can eliminate this guy. Boom. Okay. So that's your answer. So number 1, your answer is B. Let me get rid of my little stars here. Okay. That's your answer for number 1. Okay. Number 2, a little bit different. The point negative 4, 6 is a solution. Oh, 1 second, sorry. Okay. So this one, a little bit different. Same idea. The point negative 4, 6 is a solution to which of the following systems? Select all that apply. Let me see if I can. Okay, so this one, they give you the point and they give you 5 different systems. Okay, go ahead and look at the systems, or sorry, yes, actually, go ahead and look at all the systems of equations. Okay, they are all the same except their signs are different. So this one's equals, their inequality signs are different. That's the only difference. The numbers and variables are all the same. X plus 2y and 8, x plus 2y and 8, x plus 2y and 8, x plus 2y and 8. All right, negative 4x minus y, negative 4x minus y, equal, and then 10, 10, okay. The only thing that's different between all of these equations are the inequality signs. All right, just helps to notice that. So, I don't know, let's just start out by using A. So I'm going to substitute the point negative 4, 6 into my system of equations here. Okay. Oh, I should have done this while I had you pause. Let me do this. Okay. All right, so x plus 2y. So I'm going to substitute 6. Oh, let me color code just real quick. I might not do this on all of them. We were making x purple and y be green. Green. Okay. So we're going to try A. So I'm going to substitute into my first equation. So x is negative 4. Negative 4 plus 2 times y. Y is 6 equals 8. Right? I just substituted in. I'm not gonna color code on all of them because it's kind of just takes extra time. But this is purple and 6 is green. That's y. Okay. So you have -4 plus 6 times 2 is 12 equals 8. -4. Oh, sorry. -4 plus 12. That is 8. So that checks out. So it works in our top equation. Let's put my little star. It works there. Does it work in the bottom equation? Okay. We're going to do the bottom equation. So I have -4. I'm going to substitute in -4 for x. And then it's minus y. So minus y is 6. All right. -4 times -4. It's going to be positive 16 minus 6, and then equals 10. 16 minus 6 is 10. All right, so it works in both equations. So let's highlight this. Oh, yeah, let me just highlight this. No, it's not. So A, we'll just highlight A. A is one of your answers. So the point -4, 6 is a solution to A. Okay, well, since these are all the same, I should have kept my work up. Because you're just going to substitute in again. So when we substitute it in for A, hold on, what do we get? Ignore me for a second. Okay, so we got, so it was, oh, because it works. Oh, so it works. So that means that we got 8 is equal to 8. So anywhere where there's an equal sign, we got 8 equals 8 and 10 equals 10, right? We got 8 equals 8 and 10 equals 10 when we substituted in. This was the top equation, this was the bottom equation. So x plus 2y is less than or equal to 8. That's true, because it was 8. So that one would be true. -4x minus y is less than 10. Well, it was equal to 10. If we substitute this point in, we're going to get 10 equals 10. So that does not work. This is saying less than only. All right, x plus 2y is less than 8. No, it is equal to 8. It is not less than. So no. -4x minus y. This one would work because it has the equals there. But it would have to work in both, so no. So I need one that has the equals so that they are equal to each other. 8 is equal to 8, 10 is equal to 10. So greater than 8, no, it's equal to 8. Greater than 10, no, it's equal to 10 when I substitute in my point. So the only other one that works is D. Okay, I'll just go ahead and do it again to prove it to you. Oh, am I covering one up? Oh no, never mind, it's just moving around. There we go. So D, so we're going to substitute -4 and 6 into it. So x is -4 plus 2 times y, which is 6. And then it should be greater than or equal to, insert symbol, greater than or equal to 8. So you get -4 plus 12, greater than or equal to 8. -4 plus 12, so you get 8 is symbol. Oops. And so that is true. 8 is, it's not greater than 8, but it is equal to. So that's why this is the only other one that works. It's the only other one that works. Okay. sorry, I didn't do the other one, but if you substitute 6 in, or negative 4, 6 into the bottom equation, you'll get 10 is equal to 10. So that will also be true. 10 will be less than or equal to 10, which is true. You would get, if you substitute into the second equation, you would get 10 is less than or equal to 10, which is true. 10 is less than or equal to 10. They're equal to each other. So those are your only two that works. Oh, that went away. Okay, so your answers for number 2 are A and D, and that's it. So this is a solution to both A and D. Alrighty. 3 through 5, you're finding the x and y intercepts. Sorry. Okay. Let's move this guy down. Yeah. Okay, so for the first one, number 3, actually we don't need this for the first one. For number 3, this is in slope-intercept form, right? So let's pick a color, blue. So my y-intercept is negative 4. 0, y is negative 4. Okay. And then my slope is what is, your slope is what is in front of the x, so that is 1/4. 1/4 is my slope. All right, so number 3, they gave them to you, just had to pull them out of the equation. For number 4 and number 5, you're going to substitute in your zeros to find your intercepts. So let's find, to find my y-intercept, or y-intercept, we substitute 0 in for x, and what do we get? I'm going to substitute 0 in for x, so that will be 6 times 0 plus 2y equals 18. 6 times 0, 0 plus 2y. So you get 2y equals 18. Right? You would divide by 2. Divide by 2. So you get y equals 9. So your y-intercept is going to be 0, 9. That's your y-intercept. Okay? To find your x-intercept, you're going to do the opposite. You substitute. You don't know what x is. We substitute 0 in for y. So that gives me 6x plus 2, y is 0, equals 18. 6x, 2 times 0 is 0, so you get 6x is equal to 18. Divide by 6. X equals 18 divided by 6, which is 3. So that would be your x-intercept. Actually, let me get rid of my text box. Actually, I guess it's fine. There you go. All right. For this guy, same thing. So go ahead and pause me and try by yourself. You're going to do the same thing that we did on number 4. Do the same thing we did on number 4. Okay, so to find your y-intercept, you're going to substitute 0 in for x. So 3, it would be 3 times 0, which is 0. So you're left with negative 6y equals 24. Divide by negative 6. Don't forget about your negative sign. Negative 24 divided by negative 6. Negative 4. So your y-intercept is x is 0, y is negative 4. Okay. The x-intercept, remember you're doing the opposite thing, so now we don't know what x is, but y is 0. So go ahead and substitute 0 in for y. So it'd be -6 times 0, which is just 0. So it gets rid of this term for you. So you're just left with 3x equals 24, and you would divide. 24 divided by 3. 8. You get x equals 8. Oops, let's get rid of this. All right, so there are your x and y intercepts for number 4, or I guess for number 3 through 5. Oh, my graph went away. Hold on, let's move stuff up. There we go. Okay. Graph to find the solution to the system of equations. So notice you are dealing with equations, not inequalities. There's an equal sign here. So that means you're going to graph both lines, and where they intersect is your answer. That's how we do this. So let me grab a color. Hold on one second, I'm going to pause you for this. Okay, here we go. So I'm going to start out by graphing my first line. Y equals -1/2 x minus 1. So it's given to me in slope-intercept form. So my y-intercept is -1. So I'm going to graph -1. Oop, there we go. So x is 0, y is -1. So I'm saying right there. Boop. Okay. And then my slope is -1/2. Can I make this bigger? Oh, then I have to move my dot. Hold on. This is y. There. Okay. So you're going to go -1/2. So that is down 1 to the right 2. Down 1, right 2. Let me get my little circle ready. Okay, so I'm going to go down 1, and then to the right 2. 1, 2. Put another dot. All right. Then you go down 1 to the right 2. Down 1 to the right 2. 1, 2. Okay, and then you keep going. Down 1 to the right 2. Down 1 to the right 2. You can go the other way. If you want to go on the other side, then you would just do the opposite. So you would go up 1, left 2. Right? And that'll fit our little pattern here. Insert, change. All right. So you would go up 1, and left 2. 1, 2. Time. A little bit on the line. Okay, and so you would keep going up like that forever and forever. All right, gonna connect these with a line here. Really, it would be a line that goes on forever. There we go. So it's going to go through. Oh, hold up. I moved my graph. What happened to my graph here? Why are my dots all in the wrong spot? There we go. Fudge muffins. Okay. Not sure what I did there. Hold on. Let me get my graph right again. Let's insert shapes. So -1, we went down 1 over 2, down 1 to the right 2. Sorry, I didn't notice that my graph moved down 1 to the right 2. Okay, and then we would go the other way. So you'd go up 1 to the left 2. Okay, and you could keep going that way forever. Now I'm going to connect them with a line. Jeez. There we go. Should go on forever in both directions. We'll make this a little longer. Okay, that should be good enough. So there's my first line. This is an equation, so there's no shading here, only for inequalities. Your next one, my y-intercept is at -4. Insert shapes. Shapes is at -4. 1, 2, 3, 4. And then for this slope, you go up 1, right 4. So up 1, oops, up 1, right 4. Up 1, right 4. Up 1, 1, 2, 3, 4. Okay, well, they're already going to share this point. So we can kind of stop there. But you could keep going. Up 1 to the right 4, up 1 to the right 4. You could go the other way. Down 1, left 4. All right? Let me get up my line. See if I make these. Hold on. Kinda. There we go. Okay. So I graph both my lines. My solution is where they intersect. They intersect at 1, 2, 3, 4. X is 4. Y is that -3? 1, 2, 3, -3. Okay. So that is how you do number 6. Hold on. Okay. Oh boy. Hold on. Come back to me. There we go. So 7. You are graphing to find the solutions to the systems. Number 7 and number 8 are systems of inequalities. Notice they have inequality signs here, not equal signs. Okay, so here we go. Your first step is to graph the line. So graph the line y, little y equals -x minus 2. That's our first step, is to graph this line. So, all right, insert shapes. My y-intercept is -2. Okay, and my slope is -1, which means it's -1 over 1. So we go down 1, right 1. We're going to go down 1, right 1. Insert shapes. And then, oops, go again, down 1 to the right 1. And you can go on doing this forever and ever and ever. You could also go the other way. So instead of down 1, right 1, you go the opposite. So I go up 1, left 1, up 1, left 1. Okay, and you could also do that forever. I'll do it one more time. You go up 1 and to the left 1. Okay, let me draw those. Let me connect those with a line. Come back to me. There it is. Should go through -2. Okay, I'm going to extend this up. It was pretty good there. There we go. So there's my first line, and it should be solid because I have this equal sign here. So it should be a solid line. Okay. That's so annoying that it does that. Okay, we'll graph our second line. So now you're going to graph y equals -5x plus 2. Actually, sorry, let's shade first. We're going to shade first. My bad. Let's shade. No, not one. Okay. The y is less than or equal to -x minus 2. So we have to figure out which side to shade. So pick a test point. If the point 0, 0 is not on the line, I highly recommend using 0, 0, but you can use any point you want. So I'm going to use 0, 0. And we're going to substitute that into our top equation. All right. So y is 0. Insert less than or equal to -x. So that's -0, which is just 0, minus 2. So you get 0 is less than or equal to -2. Is that correct? Is 0 less than -2? No. So that means we're going to shade. What if it'll let me shade and then graph over it? I don't know. Let me just do insert shapes and I'll get my little scribbly thing. So that means the point 0, 0 did not work, so we're going to shade the other side. Whee! Okay. Okay, don't forget to shade. Now we're going to graph our other line. Here we go. Make sure it doesn't move my line. Okay. Now we're going to graph our second line. Y equals -5x plus 2. Y equals -5x plus 2. So your y-intercept is 2. 1, 2. Okay. A little off center. It's still going to be a little off center. That's better. And then your slope is -5. So that means it's -5 over 1. So you're going to go down 5, right 1. Down 5. And to the right 1. Okay, well, they intersect right there. We'll go ahead and do that one more time. We're going to go down 5. Oh, wait, let me get my thing again. Insert circle or oval, whatever it is. So here we are. We're going to go down 5. 1, 2, 3, 4, 5. Right 1. So it should be right there. Oh, that's not going to be in the right spot at all. Down 5. Oh, that was actually kind of right. Down 5. 1, 2. Right 1. Oh, that was in the right spot. 1, 2, 3, 4, 5. Right 1. Okay, so we're there. 2, 3, 4, 5. Right 1. Okay, and we're there. And then you can go the other way if you wanted to go the opposite. I'll do one of them. Up 5, left 1. Up 5. 1, 2, 3, 4, 5. Left 1. Okay, let me draw a line for this guy. Let's see. It's a pretty slanted line here. Okay. So there is my second line. So now let's shade for our second line. So once again, the point 0, 0 is not on the line, so I'm going to use 0, 0. Wait for it. Okay, so we're going to substitute 0, 0 into the second equation. So y is 0. So 0 is greater than or equal to -5 times 0. -5 times 0 is 0 plus 2. So you get 0 is greater than or equal to, this is gone, so we're just left with 2. 0 is greater than or equal to 2. Is that correct? No, 0 is less than 2, so that does not work. So 0, 0 does not work, so we have to shade the other side of the line. Let me see if I can scribble with a different color here. I don't know. I'll try and change this color after I scribble. So we're going to shade 0, 0 did not work, so we have to shade the other side of the line. Party! See if it lets me change the color. Aha! There we go. Okay, so let me go back and reshade this one a little bit. So your answer is where they overlap, where the shading overlaps. So this one was shaded over here. And then I also have some orange over here. So they overlap. They overlap right here. This is where they're both shaded. So you have to show that. Make sure you show that's where the answers are. We can even do a different color if that helps you. I know, I'll change in a second. Hold on. Thoroughly show this is where the answers are. This is where both of the shadings overlap. Let's make that. I only have 3 colors. Okay, fine, black. So that's where the answers are. That's where the shading overlaps. So that's all you do. You're done. So then for number 8, you're going to do the same thing. Okay? So go ahead and pause me. Actually, I'm going to pause me for a second. Try number 8. Okay, guys, stay with me. We're getting there. We're almost done. So for number 8, your first line, 4x plus y, is less than 2. So 4x plus y equals 2. Okay, we're going to graph this line. 2 options, right? You can find the x-intercepts like we did in problems 4 and 5 and graph using those. Or you can change this to slope-intercept form and graph from there. This was actually pretty easy to change the slope-intercept form, so I'm going to do that. So I want to get y by itself. So to do that, I'm going to subtract 4x from both sides. To get y equals 2 minus 4x, and then I'm going to rewrite it. Y equals negative 4x plus 2. Okay. Here we go. So now I can graph this line. So my y-intercept is 2. 1, 2. Okay. And then my slope is negative 4. So that means down 4 to the right 1. Down 4. Hold on. Down 4. 1, 2, 3, 4. Right 1. Okay, remember you can go on doing that forever. I mean, eventually you're gonna run out of room on your graph, but do another one. Down 4 over 1. 1, 2, 3, 4. Okay, and remember you can go the opposite way. So you would go up 4 to the left 1, so the opposite. So up 4, 1, 2, 3, 4, and 1. All right, so there's this line. Let me connect them. Somewhat connect them. We'll see how straight this is. That's pretty good. Okay. Okay, so there's my first line. So let's figure out where to shade. Once again, I'm going to use the point 0, 0 because it's not on the line. Let me get rid of some of this stuff now. Okay, so we're going to substitute the point 0, 0 into the inequality. 0, 0. You could choose any point. I just really like 0, 0. So that's going to be 4 times 0, which is 0, and y is 0. So you're going to end up with 0 is less than 2. 0 is less than 2. Is that correct? Yeah. So 0, 0 is right here. So that means we're going to shade this part of the line. You have to shade. So we're going to shade this part of the line. La, 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 la. Okay, good enough for now. Okay. Now, oh, sorry, this needs to be a dotted line. I don't know if that's an option for me. Hold on, we'll delete this. This has to be dotted line, so we'll go insert shapes. line. This is not going to be a straight. It's okay. Insert shapes. Just curve down. Dotted line. Because it's not equal to, it's only less than. Goodness. Okay, let me add one with arrows on the end. La, 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 da, da, da. Okay, so anyway, it should go on forever. Wow. Well, sorry, that was kind of hard to do. And then the other one, you have y is greater than -2. So that means you have to graph the line y equals -2. Okay. Y equals -2. That's right here. The slope is 0. Doesn't matter what x is, y is always -2. All right, so you would put, once again, a dotted line. Wish I had the option for dotted line. Okay, well, we'll try. You're going to put a dotted line. Actually, this one will be easier to make. So you just put it on this line. Nope. Going to have a dotted line that goes through y equals -2. Okay. See if I can change the color of all. No, I won't. Never mind. So then, where do I shade? Y is greater than -2. I'm just going to use 0, 0. All right. If I substitute that in, well, it doesn't actually matter. There's no x, so it's just 0 is greater than -2. There's nowhere to substitute my x, so I don't have to worry about it. Y is greater than -2. Is that true? Yeah. So 0, 0 is right here, which means I'm going to shade the top half. I'll change the color in a second. Shade the top half of my line. Okay, I'll make that orange. There. So where the shading overlaps is your answer. So the shading overlaps over here. So that means all the points over here would work in this inequality. Okay. Okay, that was number 8. Number 9, show all possible solutions to the inequality on the graph below. So once again, we are going to be graphing. Here we are. This one, you can change it to slope-intercept form if you would like. I'm going to graph it using the x and y-intercepts. See if it'll let me insert my text box here without causing too much trouble. Perfect. Oh. Okay. I'm going to graph it using my x and y-intercepts. So my x-intercepts, or my x-intercept, sorry, is y is 0. So we don't know what x is, but we know y is 0. So let's substitute 0 in for y. 5x plus 3 times 0 is less than or equal to 15. 5x. 3 times 0 is 0, so you get 5x is less than or equal to 15. You're solving for x, so now we're going to divide by 5. X is less than or equal. Okay. So my x-intercept is going to be 15, 0. Oh, that's kind of annoying. Okay, 15, 0. I'm going to count. Well, I'll wait to graph that until I find my y. My y-intercept 0, what's y? Substitute 0 in for x. So 5 times 0 is just 0. Therefore, you're left with 3y is less than or equal to 15. Less than or equal to 15. Then you would divide by 3. Y is less than or equal to 5. All right, now we can graph them. Okay, I'm just gonna count. I'm gonna count by 5s. My scale is gonna be 5s. You can count by 1s if you want, but you're gonna run out of room on your x-axis if you count by 1s. You can count by 2s. I'm gonna count by 5s. So x-intercept is 15. So 5, 10, 15. Right there. And then my y-intercept is just 5. So I'll count by 5s here too. Why not? So there we go. Okay. Okay. Now just connect them with a line. Insert. Proto-suing line. All right. And it should be solid because there's that equal. Oh, oh, oh. Okay, it's good enough. There it is. And then you have to shade. So choose a test point. Once again, I love 0, 0. As long as it's not on your line, you can do 0, 0. So substitute 0 in for x and 0 in for y. You get 5 times 0 is 0. 3 times 0 is 0. So you get 0 is less than or equal to 15. Is that true? Yeah. So that means you're going to shade on this side of the line, the side that has 0, 0. Insert shapes, scribbly line. So you're shading all over here. Okay. So that would be how you leave your answer for number 9. Oh. Move this back down here. There we go. Okay, we're almost done. See? We're getting there. So it says, solve the following system of equations using substitution. And this one we have to solve using elimination. All right, let me get my text box down here. That didn't work at all. Here we go. There it is. Okay. So your first step in solving with substitution is you have to get a variable all by itself on one side. We already have y. Y is already all alone. Oops, not the whole thing. Can I just do y? Nope. Okay, fine. Whatever. Y is all by itself. So you're going to take 5x minus 7 and substitute it in for y in this bottom equation. All right, so we have negative 3x minus 2 times y. So you're going to substitute it in 5x minus 7. Okay, and then don't forget to rewrite everything. Equals negative 12. Now we're just solving for x. Here we go. Negative 3x. Negative 2 times negative 5x is negative 10x. Negative 2 times negative 7, positive 14, equals negative 12. Let's combine our like terms on this side. So I have negative 3x minus 10x, negative 13x plus 14 equals negative 12. All right. We're solving for x, so now we're going to subtract 14 from both sides. Negative 13x equals negative 12 minus 14. 13x equals negative 12 minus 14. Negative 26. Okay. Last step, you're going to divide by negative 13. So you get x equals negative 26 divided by negative 13 is positive 2. Positive 2. So now you have x. So you did the hard part. So that's part of your answer. Here's half my answer. Now I need to find y. So you can take you can take 2 and substitute in for x in either equation. We're going to do the first one. So I have y equals 5. Substitute in 2 for x times 2 minus 7. Y equals 5 times 2, which is 10, minus 7. 3. Y equals 3. So there is your answer. We solved it using substitution. Actually, I can just delete this whole thing. There. Nah. Whee! So highlighted. There. And then number 11, you're going to solve using elimination. Oops. Text box again. Okay. So your first step in elimination is to make sure they're lined up. Are my x's and my y's lined up? X, y, no. Okay, so I'm going to leave the first equation the same, 3x plus 5y equals -1. And I'm going to switch to the bottom equation so they're lined up. So 2y plus x, so it's going to become x plus 2y equals 1, small x. There. Now they're lined up. Okay, next step. I have to have the same coefficient in order to eliminate. So I have 3x and x. Those aren't the same. I have 5y and 2y. Those are not the same. So I'm going to multiply this bottom equation by 3. Then I will be able to eliminate x. Multiply it all by 3. Okay, so that will give you 3 times x is 3x. 3 times 2y, 6y. And 3 times -1 is -3. Okay. So that's your new equation. Boom. Ah. Okay, phone. Got it. Okay, now we can eliminate. So we're trying to get rid of our x's. So are we going to add or subtract these two equations? Here, let's. There. If we add them, we'll get 3x plus 3x, and that's 6x. We're trying to get rid of x, so we're going to subtract. So you get 3x minus 3x's, that's 0, so your x's are gone. Then you have 5y minus 6y. 5 minus 6 is a -1y. You don't have to write the 1. -y equals -1 minus -3. So that's -1 plus 3. -1 plus 3. That's 2. So you have -y equals 2. So you're not done. You have to get rid of the negative by multiplying or dividing by -1. So you get y equals -2. All right. Once again, you're halfway done. Let me move this up a little bit. This is kind of annoying. Okay. Halfway done. So we still don't know x, but we know y is -2. So to find x, substitute -2 back in for y in either equation. I'm going to do the second one. So I have 2 times y, which is -2, plus x equals -1. -4 plus x equals -1. And then we're going to add 4 to both sides. So you get x equals 4 plus 1 is 3. All right, so there is your answer. Whew. Okay. Perfect. Finally, number 12. We're almost done, guys. Fill in the blanks. For linear equations, if the slopes are blank and the y-intercepts are blank, then the lines are parallel and there is no solution. Okay, so if you have, we're talking about linear equations here, system of equations. So it's equals, not an inequality. So what makes it have no solution? What makes the lines be parallel? To be parallel, the slopes are the same. Slopes are, we'll put the same. Oops. The same. And the y-intercepts are, if they're parallel, then the y-intercepts are different. Then the lines are parallel. There is no solution because the lines will never, ever, oh my goodness, click on it, thank you, intersect. They will never intersect. Parallel lines never intersect. Never intersect. All right. So that's what you do for A. B, for linear equations, if the slopes are blank and the y-intercepts are blank, then they are the same line and there are infinitely many solutions. Okay, well, they're the same line. So the slopes are the same. And if they're the same line, then the y-intercepts are also the same. They're exactly the same line. So everything is equal. Everything is the same. Last one, for linear equations, if the slopes are blank, then there is one solution. The lines will intersect at one point. Different. If the slopes are different, they will intersect at one point. Doesn't matter what the y-intercepts are. If the slopes are different, they will intersect at one point. Woof! There you go. Make sure you shaded your inequality graphs. Thank goodness we did it.